to find us as we move on. I hope you guys can hear me very well. So today we have chemistry. And let me try sharing my screen here. All right. Who can remind us on what we looked at last time before we begin? Who can remind us on what we looked at? You can raise up your hand and tell us, yes, Christine?
Chemical properties of oxygen. Chemical properties of oxygen.
Chemical properties.
Pardon?
Chemical properties of oxygen. Okay. That's good. That's good. Any other? Rashida, do you have something to say? Okay, that is correct. We looked at the chemical properties of oxygen. How oxygen reacts with other elements, which is good. Again, this lesson is brought to you by Yaaka. These are free lessons that we are I hope about how digital learning can be beneficial to you all. If they haven't, then they will very soon. Okay. So today we'll be looking at oxides. We'll concentrate on oxides. If you can't hear me well, please you type in the chat box so that I can know. I'm saying something, probably. So who can tell us, what do you think oxides are? What do you think oxides are? How can you explain an oxide if you asked? What is an oxide? We can try. Oxide. Yes, Elisha?
I think oxides are chemical compounds with one or more oxygen atoms.
Hey, that's good.
Yeah.
That is Joel. Thank you, Joel. Rashida.
An oxide is a compound formed when an element reacts with oxygen.
Okay, a compound formed when an element reacts with oxygen. Those are all very good ideas, and you guys are correct. So we look at when an element reacts with oxygen, what it forms is an oxide. Okay, and this is exactly what we look at. Most elements formed after reacting with oxygen, some of them will always be colored, and all these, the pictures you see here, are oxides. Okay, so some of them are colored, some of them are just white, white powder, or just gases, or yeah. Okay. Let us continue. Oh, someone wrote in the chat box, Solomon Tatwebwa, put off your video to save the quality of the sound. Solomon Tatwebwa is the teacher. Okay. Let's continue. So yes, an oxide is a compound of oxygen with a compound of oxygen with another element. And we are going to look at the classes. So like you guys said, when an element reacts with oxygen, whatever forms is an oxide. Okay. Oxides, and I have examples here of basic oxides. Now, who can define for us a basic oxide? What do you think a basic oxide is? Rashid, you have your hand up. Are you answering the question or you forgot your hand up?
No.
Okay, Stella.
A basic oxide is an oxide which, when dissolved in water, forms an alkaline.
Okay, when dissolved in water, it forms an alkaline solution. That is good. Any other? Any other suggestions? Okay, that's good. That's a good explanation. Basic oxides will always form alkaline solutions once dissolved in water. So sometimes we just say that there are metals, oxides of metals, which react with acids to form salt and water. Okay, that brings about the definition of also just a basic compound. Okay, so anything basic. Players said oxides are metal oxides which react with acids to form salt and water. Yes, they are metal oxides that once they react with acids, they form a salt and water. And here is what we mean. For example, in this reaction, we see magnesium oxide, which is a basic oxide, reacting with hydrochloric acid, okay, forming a salt, which is magnesium chloride, and our water here. All right, this is what we mean when we talk about basic oxides. They are able to react with an acid to form a salt and
Water.
Another example we can give is here from copper 2 sulfate, copper 2 oxide, reacting with your acid, sulfuric acid, forming a salt, copper 2 sulfate, and water. Okay, so that is the definition of a basic oxide, and that is how they come about. That's how they react, that's how they behave. Once they react with an acid, they form a salt and water. Okay, any questions about this?
No.
Okay, very good. We can continue if you don't have any questions. The other class of oxides we can look at is acidic oxides. Okay. Now these are mostly gaseous in nature. They're gases in nature. And as you can see, I have a couple of pictures of some. You always know that carbon dioxide can be found in the atmosphere, so I put something that looks like carbon dioxide here. And then in most industries, you see the release of oxides like sulfur dioxide and things like that. Then right here, I have nitrogen dioxide in the chemical flask. And then I also have another oxide here. This could be sulfur trioxide. Looks like that in the gaseous phase. So, who can define for us acidic oxides? What do you think acidic oxides are? Before we explain what are acidic oxides? Yes, Christine?
Acidic oxides are oxides of non-metal that dissolve in water to form acidic solutions.
Okay, that's very good. Good job. Amira, you have a different idea?
No.
Amira, you have a different idea, or it was the same?
It was the same idea I had.
Okay. That is correct. Bonita also correct. So when we look at, Bonita wrote in the chat, she's also correct. When you look at acidic oxides, we can dissolve them in water and they form acidic solutions. That is their distinct nature. That's what makes them who they are as acidic oxides. Dissolve any acidic oxide in water, you'll form an acidic solution, right? We see some of these acidic oxides when they're in the atmosphere in plenty. You've heard of acidic rains. Most of those acidic rains are formed by these acidic oxides in the atmosphere, okay? So that's the thing with acidic oxides. Sometimes we call them anhydrides. Sometimes we call them acid anhydrides, okay? Acid anhydrides. This it shows that once those acidic solutions or to release, it will be able to form hydrogen ions in solution as the only positively charged ions. Okay. All right, Kanya was also writing in the chat box. Kanya, that is correct. So the other thing we can talk about these acidic oxides is the examples that we can give. We have carbon dioxide, sulfur dioxide, sulfur trioxide, and nitrogen dioxide, and many others. Carbon dioxide dissolves in water to form carbonic acid. And as you can see the equation here, we have our carbon dioxide reacting with water. So we are dissolving carbon dioxide into water to form our carbonic acid. Okay, forming our carbonic acid. And then when you look at sulfur trioxide, when we dissolve sulfur trioxide also in water, dissolve sulfur trioxide in water, what we get is sulfuric acid. This is key. This reaction here is key in the formation of sulfuric acid in the laboratory or even on a large scale. We've seen that, we can always see that in that experiment where we form sulfuric acid. Sometimes we call, I think it's the contact process, if I've not forgotten, where we form sulfuric acid from sulfur trioxide. Okay, it's very key. These oxides react with alkalis to form salt and water. Carbon dioxide reacts with sodium hydroxide to form sodium carbonate and water. So when these oxides react with alkalis, who can tell us what alkalis are? Who knows what alkalis are? The term alkali. What are alkalis? We have an example here of sodium carbonate. So I should give you a clue on what we call alkalis. Rashida? Yes, Rashida.
This is a compound which produces hydrogen ions when it dissolves in water.
Okay. Good try. That's a good one. That's a good try. But for example, if you dissolve sodium carbonate in water, will it form hydrogen ions? It is very hard for it to form hydrogen ions. Okay, to form something else, which are hydroxyl ions, not hydrogen ions. Okay, but in a simple way, salts that are formed from group 1 and group 2 elements, most times we will call them alkalis. Okay. So salts from those two groups, we sometimes refer to them as alkalis. All right, not alkalines. Alkalines is different from alkalis.
Pardon.
That is very, very important for us to remember. Good job. So if dissolve them in water, you form them. Yes, I'm repeating what you have said. Acidic oxides, when you react them, you form acidic solutions as you react them in water. This morning, I don't know why my internet is somehow slow. It doesn't normally do that. But nevertheless, we shall continue and it will get better as we move on. The other thing we have talked about is that when you react these acidic oxides with alkalis, you form salt and water. Okay, so those are the two major points to pick up from here about acidic oxides. You have to remember they are oxides of nonmetals that when you dissolve them in water, you form acidic solutions. That's the first statement you have to remember. The second one is that once you react them with an alkalis, you'll form a salt and water. And we have seen an example of sodium carbonate reacting with carbon dioxide. Very good. To form, so carbon dioxide reacting with sodium hydroxide, forming sodium carbonate and water. So those are the key things that we can pick up from this particular class of oxides. Any questions so far? Okay, I'm pausing so you can ask. Innocent, you have a question?
Excuse me, teacher. I wanted to ask, is rain itself, isn't rain not acidic itself?
Okay, that's a good question. Yes, you'll find that in most the raindrops, if you test them, they'll be slightly acidic, okay? Slightly acidic because of dissolved carbon dioxide, of course, which we find in the atmosphere. In areas where the environment has been polluted so much, where there is a high amount of carbon dioxide in the atmosphere than normal, you'll find that the rain there is more acidic than usual, okay? It will be more acidic than usual. But the normal rain that we have is just slightly acidic. It is not, it's not that that much acidic that it can even destroy plants and things like that. No, it's just slightly acidic.
So it forms weak acids. So can carbonic acid be put among that?
Yes, carbonic acid is an acid. Is a weak acid, but it's still an acid. Okay.
Okay.
Which is, yeah, we have it right here. When carbon dioxide dissolves in water. So, yeah, that's a very good question. In areas that have been polluted, it is really, 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 really bad. Like the rain, when it rains, crops die because of the carbonic acid found in the rain. Okay. But in our areas this side, which are not that much polluted, we hardly have acidic rain. Sometimes acidic rain can contain other acids, not only carbon dioxide, because of these acidic oxides. Most of these acidic oxides are found in polluted environments like carbon dioxide, sulfur dioxide, nitrogen dioxide, all those you can find them in the atmospheres of polluted environments. So the rain that will come down will really be very, very acidic because it contains even other acids. Someone asked in the chat, what is the chemical formula of sodium carbonate? Who can tell us the chemical formula of sodium carbonate before Amira asks her question? What is the formula of sodium carbonate? Who knows? Formula of sodium carbonate. Okay, Kanya tried in the chat. That's a good try, but you're missing something. Who else wants to try? Formula of sodium carbonate. You can write it in the chat if you can't spell it out, and we see. Hamira wrote, okay, Hamira, you're correct. Make sure the O is capital. But also, there's something is missing. You messed up somewhere. Yeah, you were almost there. Almost there. Who else wants to try? Let's see. I can see Bonita. Bonita, you're correct. Abu Christine, you messed up somewhere. Also, Tracy, you messed up somewhere. Look at Bonita's formula. Bonita's formula is the correct formula here. And Hamira, yours is now also correct. Okay. Rashida, yours is correct. Yes, so we have Elisha, yours is correct. So we have Elisha, Rashida. Who else? I saw Bonita. Was it Bonita? Yes, Bonita, yours is also correct. And who? And Hamira. Blair, you're correct. So yeah, look at those that I've said are correct. That's the formula of sodium carbonate. Let me try to type it here so that you can all see it. So we have sodium, okay? Sodium has valence 1. Sodium has valence 1. And the carbonate has valence 2. So the 2 of the carbonate will come here on sodium, like that. You just have to make sure that when you're writing it, these are subscripts. The numbers are subscripts. Okay? So that's the formula. All right. If you've not seen it, just check in the chat. Bonita wrote a correct one, and Laisha and Blair and Hamira, I think. Some people wrote a good ones. Okay, good job. I think Amira had a question before we went into finding the formula of sodium carbonate. So Amira, ask your question.
I was asking that what about that dew that forms in plants in the morning?
The what? I didn't hear you well. The two?
That dew.
Oh, that dew.
That forms on plants in the morning.
Hey. Okay, that's a very good question. Who knows how dew is formed? Who knows how dew is formed? Amira is asking about the dew formed in the morning. Does anyone know how dew is formed? Who would like to try? Okay, so as you know, in the night, okay, most of the nights, the temperatures always drop, all right? When the temperatures drop, the water vapor, okay, that was in the atmosphere while the temperatures were high during the day, it condenses. When it condenses, it falls down as water droplets, and you'll find it on things that you left outside or on plants that you'll see in the morning. So it's just water vapor that has condensed because of the drops in the temperatures during the night. Okay, so that's how dew is formed. Now, the other ways it can be formed, but that is the typical one. Now, if you're asking if that dew is either acidic or not, it will depend the amount of carbon dioxide we have in the atmosphere. If we have a lot of it, carbon dioxide or any other acidic gases, that dew will absorb the gases and it will become acidic if we have a lot of it. But that is very rare, okay, to have dew that is acidic. Very, very, very rare. Because most of these gases will be found in the higher atmosphere, not in the lower atmospheres where the dew is formed. So that's the difference. Okay. Gift, do you have a question? Your audio is on.
No.
Okay. Turn off your
I
audio.
don't have a question.
All right. Turn off your audio then. Good job. All right. So now we know acidic oxides. And if you have any other questions of acidic oxides, please ask. Okay. Those were very important questions that you asked. Good job. Let's look at neutral oxides. Who can tell us what neutral oxides what they are quickly here? Neutral oxides, who knows? Yes, Amira?
There are oxides that do not show whether they are basic or acidic.
Very, very, very correct. Okay. These oxides do not show whether they are acidic or basic. They are not acidic or basic. They don't have any of those properties. Okay. So those are the neutral oxides. They're basically mostly non-metal oxides. They're formed from non-metals. Yes, Bonita, you are also correct. Yes, I was saying that they do not form acidic or basic solutions. They don't have those kind of properties. So for them, they are neutral. They test neutral to litmus paper. If you put a damp litmus paper in a container containing these oxides, it will not change. Okay. It's not like the acidic oxides. These ones are quite neutral. What is the chemical formula of phosphorus pentaoxide? Okay. Who knows the formula of phosphorus pentaoxide? Would love to try to write it? Someone is asking in the chat box. Phosphorus pentaoxide. Kanya is asking about phosphorus pentaoxide. Let's see who can write it. Christine, good try, Christine, but that is phosphorus acid. No, phosphorus acid has even a 3 on the oxygen. Let's see from Bonita, P2O4, 5. That's good. So look at Bonita's formula. So they tell you, when you see the words like penta, di, penta means how many? 5, not so? So it means that you have 5 atoms of oxygen when they say pentaoxide. Okay, 5 atoms of oxygen. So that's what you just have to remember. And you know the valence of oxygen is 2. You cross that 2 over the other side and you have yourself a formula. Okay. So these oxides, which are neutral, they don't react with water to form any acids. Neither do they react with acids to form salts. The examples we have are carbon monoxide, nitrogen monoxide, dinitrogen oxide, and water, which is hydrogen oxide. Anyway, you can always add that. A question I have here for you is about carbon monoxide. Where is carbon monoxide produced in your daily environments? Like at home, where do you produce it? Or where is it released? There is an activity or something you do at home that results into the release of carbon monoxide. Not carbon dioxide, but carbon monoxide. Let me tell you some of the characteristics of this gas. This gas, when you breathe in this gas, you immediately start choking. Okay, you choke, and sometimes it is even irritating on the eyes. Okay, from burning charcoal in limited supply of oxygen, that is correct. Burning wood, that's also good. Any other? Yes, burning charcoal is correct, Rashida. Now, the most common one where we form a lot of this carbon monoxide is, have you guys lit a stove, the paraffin stoves? And then when you blow it, the gas that comes out, the way it chokes and the way it irritates your eyes, that is a lot of carbon monoxide right there. Okay. Even in gas stoves, yes, that is correct. Even on gas stoves, sometimes you see that the gas can be produced there, this gas. But mostly the paraffin stoves, that choking kind of irritation it gives you, and also on the eyes, that is its characteristic. So always remember when you blow paraffin stoves, make sure they are outside, not inside your house, because when they are inside, you can breathe in this gas, and this gas is very poisonous. Okay. Carbon monoxide, very, very, very poisonous, not good for your lungs, seriously. So it's important to remember that. Okay, good job. Any questions?
No.
Johnson is asking, what are we talking about? Johnson, you joined late. We're talking about oxides, okay? Just pay attention to the rest. Okay, we have another type of oxides. We call them the amphoteric oxides. Who can tell us what amphoteric oxides are? What do you think amphoteric oxides are? Yes, Hamira.
These acids, for them, they show both acidic and basic properties.
Okay, amphoteric oxides show both acidic and Rashida.
These are metal oxides which show both acidic and basic properties.
Okay, they can be metal, sometimes they're not, but good good job. That's a good one also. Christine?
Amphoteric oxides are oxides of metal that react with both acids and bases.
Okay, very good. Those are all great submissions. Okay, they are great submissions. So as we can see, most of these are metallic and they show both acidic and basic properties, just like you said. They react with both acids and alkalis. Okay, to form salt and water. Yes, Martha, you're correct in the chat. Exactly. So we have examples here. Aluminium oxide, and we have lead 2 oxide and zinc oxide. Those are the most common examples of amphoteric oxides. Amphoteric oxides, when they react with, for example, here we're having a very good example of zinc oxide reacting with sulfuric acid. And when this happens, we have our zinc oxide here reacting with sulfuric acid. You form a sulfate, which is a salt here, zinc sulfate, and then with water. Okay, that is the reaction. That's the reaction of zinc oxide and sulfuric acid. Okay, remember these can react with both alkalis and acids. Okay, here an example, we have the picture you're seeing. This is, who knows what this is? This oxide, this color. Who can tell us? Yes, Christine? Christine, do you know? Christine, do you know this oxide? Your hand was up. Who knows this oxide that is on the picture? Who wants to try? Which amphoteric oxide is this? Innocent, do you want to try? Okay, this is lead oxide or lead 2 oxide. Shani, a good try. Zinc oxide is that color when it is hot. When it's cold, it goes back to white. Lead oxide, that is correct, Kanya, but that's not the formula. Someone has their audio on. Johnson, turn off your audio. Okay, good job. We can see some of the other reactions, and we are going to also to see how they react with alkalis, but let's start with how aluminium oxide reacts with hydrochloric acid. So we have aluminium oxide here, which is another example of our amphoteric oxides reacting with hydrochloric acid. Our products are aluminium, chloride, and water. So we always form a salt and water. That is very key to remember to lead you on the correct answer. Okay. Another reaction we can have is between now an alkalis and the amphoteric oxide. And here we're going to use zinc oxide reacting with sodium hydroxide. Okay. Now, here our result is a complex, the sodium zinc complex. Okay. You can call that sodium zincate. The spelling of zincate is right here. It's a salt complex. that we form when zinc oxide reacts with sodium hydroxide. We form sodium zincate. Okay, it's a complex. Normally, when these amphoteric oxides react with alkalis, they form complex salts. Right? So another example is here where we can form another complex. Aluminium oxide, our amphoteric oxide, reacting with sodium hydroxide. What you form is sodium aluminate. So once you see hydroxyl ions with a valence of 4, okay, right there, with a 4 outside here, we always name that as the metal that is attached, and we add ATE. Okay, so this is an aluminate, and up here we have a zincate. So those are complexes. Okay, you don't have to remember that all the time, but you just have to know that amphoteric oxides react with both acids and alkalis. When they react with alkalis, you form complex salts. Questions? Do you have any questions on this? Something you don't understand?
No.
Scovia, your audio is on. Scovia, your audio. Okay, if there are no questions, let's look at the peroxides. The peroxides, they contain twice as much as the oxygen as they would contain in their normal oxides. So these ones just have more affinity for oxygen, and they carry a lot of it compared to their normal oxides. For example, the normal oxide of sodium would be, of course, sodium oxide, right? We would have, the normal one would be sodium, okay, oxide, like that, right? But now we see more oxygen atoms on this one, okay? But the normal one would be without the extra oxygen atom. So these ones contain double the oxygen they should have in normal circumstances. That's why I write sodium peroxide like that, okay? So normally it would be like this. Normally we would have that, but now we see that it becomes a peroxide once it absorbs more oxygen atoms. That's why we call them peroxides. They have extra oxygen atoms as they would have when they are just normal oxides. Another one is here, hydrogen peroxide. Normally it would be just H2O, water, but it becomes a peroxide once it absorbs an extra oxygen atom. Those are the peroxides. Okay. I'm sure most of you have seen a peroxide before. Some of you, when you get sick, not even sick, when you get an injury, sometimes you use this hydrogen peroxide to treat the wound. It's always sort of it's a liquid, milky sometimes, or colorless, but once it's poured on the wound, it brings out that reacts with the tissues around the wound, and very many bubbles are formed. I don't know if you have been treated with this before. Sometimes they just use iodine. Okay. So those are the peroxides. Any questions on the peroxides? Questions on? Okay, good job. Good job on this one. Please, if you have questions, make sure you ask. Remember to ask if you have questions. Lastly, let's look at the mixed oxides. Barium peroxide is a peroxide, okay? So yes, Bonita, you're correct, okay? All right. So these ones react like a mixture of two simpler oxides. For example, lead tetraoxide, tri-iron tetraoxide. Those are the few examples we have of mixed oxides. Okay? They react as if they have a mixture of two simpler oxides. Yes, please, you had a question? Yes, please.
I was asking a question about the peroxide. Can they also react with other oxides?
No, oxides cannot react with other oxides.
Okay.
Good question. We were talking about the peroxides. These ones behave like it is a mixture of two simple oxides. This is why we have an example of lead tetra oxide. Okay, normally it will just be lead oxide, but now that it's behaving as if they are two combined, you have extra oxygen atoms, making it a tetraoxide. The other example is tri-iron tetraoxide. Normally it will just be iron oxide, but then you get, since it is reacting as if it is behaving as if there are two simple oxides, becomes a tetraoxide. Those are the mixed oxides. Mixed meaning it is sort of a mixture of two simple oxides. Okay, that's one thing we need to know about them. That formula is good. Okay, good job. If you don't have any questions, but if you have, let me pause so that you can ask. Any questions about the whole lesson? Let me see what is in the chat box. How different is dinitrogen from nitrogen? Who can tell us the meaning of di? What does di mean? Di. What does di mean? Christine says two, that is correct. Tracy says two, that is correct. Di means two, okay? So yes, very correct. So dinitrogen, it means two nitrogen atoms, okay? So for example, when you look at dinitrogen oxide, we have two nitrogen atoms and one oxygen atom. So that's the difference. Nitrogen is just an element, one atom. In nature, it exists as a diatomic molecule, not atom, but molecule. Okay. All right. So again, like I told you in the beginning, please make sure that you show this to your parents and encourage them to attend the meetings that we are having about digital learning. I think we sent out links in all the groups so that they can know, you guys can know together with your parents the benefits of digital learning in this new era, such that you guys can subscribe to our Yaaka, and then we can continue learning seriously, because I believe this is very important for us to continue learning, even though schools are closed. And I've enjoyed even just being with you, teaching you guys. You're very, very, very active. I like that. So I would love the relationship to continue. I don't want to miss any of you. So please, at 11 a.m., make sure you attend, and encourage your parents to come also and attend at 11 a.m. All right. See you then. Stay safe, stay well. Thank you for attending. If you have any questions, please ask. Any questions?
No.
Okay, good job. Well done.
11 a.m. today.
Thank you, teacher.
You're welcome.
Thank you.
You're welcome. Innocent, do you have a question? Or Johnson?
Yes.
Mm.
Now, in terms of oxygen as dioxygen, and when the person asked about if oxygen can what? Can react to each other. Now let's put it in terms of bonding. Which bond can oxygen be put in?
Which what?
Let me say like dioxide. Let me say a compound like that. Now let's put it in terms of bonding. In terms of which bonding can oxygen be put in? Because ionic bonding mostly differs to what? Metals,
Okay,
covalent.
that's a good question. Yeah, in bonding, oxygen will bond with other elements. Like we have seen in the oxides, you see a metal being bonded to an oxygen atom. That is ionic bonding right there, a metal and a non-metal. Oxygen is a non-metal and you're having a metal too, right? So that kind of bonding can take place. But the question that that person asked was about oxides reacting with other oxides, okay? Peroxides reacting with other oxides. That is impossible to take place, okay? Unless any other circumstances are put in place, but naturally they cannot react, okay?
Yes.
Oxides with other oxides, yeah.
Okay.
Innocent, that was you, right?
Yes.
Someone else had a question? Okay. If there are no any other question, the host wants to talk to you or has a question. Yes, please.
Thank you, Teacher Solomon, for the lesson, and you guys for attending. Teacher Solomon, we also need to take chai. So, meanwhile, at 11, there is a meeting and a class. So this meeting would best be attended by your parents. So inform your parents you have been conducting online classes, and the ones who have been conducting online classes would like to talk to the parents about how we pay and the advantages. Then for you, you can be in class. Is that okay? Because you shall have math, and then the other side there is a training. So inform your parents so that you don't miss out this chance. Otherwise, have a good day. Thank you, Teacher Solomon.
Welcome. All right, bye guys. See you later.
Bye.
Bye.